Welcome back, guys. Today I am going to discuss horizontal circular motion. So now questions only I will explain here. Question number one. So very simple one first I'll take. A particle moving with a speed of, actually I have a chance to micro thing, moving with a speed of 10 meters second on a circular track of radius 25 meters. Now the driver of car applies the brake, producing the a uniform retardation or deceleration. A uniform deceleration of 3 meter by second. So then the questions are going to ask like this. So first of all, given data C, particle moving with the speed of 10 meters second. So speed v is equal to 10 meters second. So radius r is equal to 25 meters. So you apply the producing retardation a is equal to, so 3 meters second power minus 2. 3 meters second power minus 2. So now, so this a is linear acceleration, that equal to at we can say. At is equal to 3 meters second power minus 2. So now acceleration, if he is asking means acceleration after just applying the brakes, the root over we know an square plus at square. So here according to given data, an is equal to v square by r, that equal to root over 100 by 25 plus 100 by 25 whole square plus t square. So that is equal to, so here 416 plus 925, 5 meter second power minus 2. So now sometimes they will ask, so what is the direction of acceleration? So actually this is the particle moving in a circular path. So this is v bar direction and at bar also. So now this is an bar. The an is always in direction of towards center, it is tangential. Now this is a bar. So here this is the a bar direction. Here this is the a bar direction. This is a bar. At, an, an, at. So the a bar direction changes as well as magnitude change. Magnitude makes constant. So acceleration in a circular particle is changing, continuously changing. Velocity changes. Speed can be changed or constant. Uniform circular motion means it is constant. It is non-uniform motion means the speed is varies. But the uniform circular motion, non-uniform circular motion, both the motions, velocity is varies continuously, even though it has same magnitude or constant magnitude. So now acceleration, so direction with velocity or motion means this is the theta. So now I can go with the tan theta. So this is the direction of an now. So these two are parallel vectors. Therefore, tan theta is equal to, I can go with the an. An means normal acceleration v square by r. That equal, here I got 4. 4 by tangential acceleration. The tangential acceleration is 3. 4 by 3. Therefore, theta is equal to 4 by 3 means 53 degrees. That is the answer. So now this is acceleration direction at any instant. This is the total acceleration, net acceleration. An is equal to, from the given data v square by r, the an gives, at is given, tangential acceleration. So then I can find. So the next question. So this is related to kinematics of circular motion. They are given theta is equal to 3t plus 4t square. So now, so we know angle kinematics omega is equal to d theta by dt, that equal to 3 plus 8 derivation. So angular velocity is varying with respect to time. Here angular velocity is not constant. Time changing means angular velocity also changes. So now angular acceleration alpha is equal to d omega by dt. So that is equal to 8. 8 radian second power minus 2. So here it is radian second also. So you people very clear that alpha is equal to omega by dt and derivation how to do these terms, right? Omega means 3 plus 80, how to do the derivation. 3 is constant. Parental in derivation basic mathematics, you know all these things. So now in this, they can ask question. The centripetal acceleration they're asking. So when they're asking centripetal acceleration, A is equal to R into omega square. So since it is V is equal to R omega, therefore by actually V square by R, that is equal to R omega square. This is centripetal acceleration, AC or AN. So that is equal to R is equal to radius. So radius is given, for suppose radius is equal to 1 meter is taken. It is given value. Therefore 1 into omega square. So omega square means 3 plus 80 whole square. So at t is equal to 1, the omega at t is equal to 1 is equal to 3 plus 8, that is equal to 11. So 11 square. So 121 meter second power minus 2. In this note out at all. So now they can ask AT, tangential acceleration, is equal to R into alpha. So here you need to remember one point very clearly, that is, so AN is equal to normal acceleration, that is the rate of change in velocity by turn. But AT is equal to the rate of change in speed, not velocity, magnitude of speed by d. AT is equal to rate of change in speed. So which is equal to d by dt of R omega, you will get as R alpha. So AN is equal to rate of change in velocity. Okay, we have to find out first velocity, which is not equal to R omega. So here it will be the velocity bar is equal to omega bar cross R bar. So velocity bar is equal to omega bar cross R bar. That is, now here it is R alpha. So that equal to R already 1 is given and alpha equal to 8. So that equal to 8 meter second power minus 2. Right? This is. So now next they can ask the acceleration of the particle at t equal to 1 second or t equal to 2 seconds, whatever the time we get. So these two are AC and AT. Therefore acceleration is equal to, we know clearly that equal to root over AC square plus AT square. So substitute now 121 whole square plus 8 square root. So finally it is equal to 121.826 meters second power minus 2. So 121 whole square plus 8 square means 64, something that is equal to 0.26. So these are the questions can come up with. So related to final velocity after t equal to something, like that also they can ask questions. When the final velocity becomes to 0, after what time the final velocity becomes to 0. This is the velocity at any instant. So it is 0 means not possible, right? T minus the omega is equal to 0, final velocity omega means at what time the velocity means it is not becoming 0. Initially at t is equal to 0, 3 radian second inverse is the angular velocity. So it never becomes 0. It is increasing only, right? So with constant, the change in velocity is constant and alpha is 8 radian meter. So alpha is constant. Therefore, change in angular velocity is also constant. Angular velocity changes, but change in angular velocity is constant, right? So this is. So next question, another model of the question. So I'm taking the questions like multiple concept is involved. That's why means all the points I can explain. So only I'm taking like this. So particle moving in a circle path of radius 2 meters. So given radius is equal to 2 meters. This is the step 1 you have to follow. With a constant velocity, constant angular velocity omega. Angular velocity is given. In the time t is equal to pi by 3 omega. So now omega angular velocity, it is moving in angular velocity with angular velocity in the circular path. That is given. So with t is equal to means in time t is equal to pi by 3 omega. So what can I find out? Final velocity I can find out. But here given constant angular velocity. So means initial and final is equal to same. Therefore alpha is equal to 0. So now this is uniform circular motion I can say. Alpha is equal to 0 means v is equal to constant. Therefore speed is equal to constant. So uniform circular motion I can say. So there is only acceleration is equal to AN. So that equal to R omega square or V square by R is equals to. So R is given. So now here V I have to find out. V is equal to R omega. So V I want to find out here. So in T is equal to 3 by omega, the particle is coming into here. The particle is coming into here in. So this is the angle covered. In T is equal to pi by 3 omega seconds of time taken from particle is A to B traveled. So now this is equal to angular displacement. Therefore we know very clearly the angular displacement theta is equal to omega into T. So that is equal to omega means omega only. So constant angular velocity is given into time is equal to here pi by 3 omega. So pi by 3 that equal to how much will come 60 degrees. So it is covered 60 degrees. So in T equal to 3 pi by omega. So to cover constant angular velocity is given. Therefore to cover 360 degrees it takes 6 times of T. That equal to 2 pi by omega. That is clear, right? So now that is clear. Here time is equal to 2 pi, capital T is equal to 2 pi by omega. So then in pi by 3 omega seconds it is covered angle theta is equal to 60 degrees. So when I know the theta value, so this type of question they can ask. One is, so here if you see AB is the angular means length of the arc. So here AB is represents what here in this length of arc means length of the length covered by the particle moving in a circular track or circular path. Length of arc. AB is arc now length of arc. That is equal to theta by 360 into 2 pi r. R is the radius here. So theta is equal to 360 theta by arc is equal to theta by 360 into 2 pi r. So now to take here, so this is called the straight line. So which is joining this. So this is a displacement. AB is the displacement here. AB bar is displacement. So now take the vector addition and follow the displacement. I will get finally 2r sin theta by 2. So this is displacement. So now distance traveled AB is equal to the distance AB is equal to magnitude of displacement. So that equal to r into theta. This is distance. Distance formula r into not 12 into r into theta. So we know very small from many times in optics we use this one very means often we will use this. So for small angles, theta is theta. That's all. Sin theta is equal to theta. Similarly, tan theta is equal to theta. Cos theta is equal to 1. In derivation and optics will use this one in proving some concepts. So there we use this small angular approximation. And in rotatory motion, circular motion, also circular motion main very important this is. For AB is equal to r theta. So now I can find out the values. The distance is equal to r is equal to here. The radius is equal to 2 meters. Theta is equal to pi by 3. So pi by 3 meters is the distance. So now coming into displacement, 2 into 2 into. So theta equal to pi by 3, that equal to pi by 6 means sin 31 by. So 2 to get cancelled. Displacement equal to 2 meters. So distance is coming in 2 by 3 into pi radians. So 3 point something. So it will be more than 2. Distance is more than displacement, you know very clear. So distance is more than displacement. In kinematics we studied it is very important. Distance cannot be less than displacement. Okay, displacement can be less than distance. Okay, where displacement is 0, distance may or may not 0. But distance 0, displacement must be 0. These are all statement type questions or conceptual questions. In IIT, there is a less chance to ask this type of models, right? But in assessment regions, they can ask like this. That means displacement 0, but the length of the path is covered. Displacement 0 means one cycle completed means displacement 0, but distance is equal to 2 pi r for one cycle. Similarly, in straight line, displacement and distance are equal, but sometimes means in all the ways, distance is more than displacement. There is no chance displacement can be greater than distance. There is no chance at all, right? So these are the some important points related to displacement distance. Here topic came, that's why I'm telling, and he's asked to find out the distance and displacement. So they can ask like that type of mass m is equal to given data, mass m is equal to 500 grams. So that equal 0.5 kg or 1 by 2 kg. Radius of circle path is equal to 16 meters. So that the normal acceleration varies with time. The normal acceleration varies with time is equal to 90 square. So this is very important. On this one more problem, very important one. Right. So now from this we can find out first you have to find out v bar means speed. So when we know the speed, From that speed, we can find out the tangential acceleration. AT is equal to dv by dt. So then we can find out the A net, because already AN is given, therefore A net is equal to root over AN square plus AT square. So then A value is there now, then F equal to MA will come. Total force. Centripetal force means MAN, tangential force means MAT. So your force is total force is equal to net force is equal to MA. So from this you can find out power. Instantaneous power at any instant is equal to F dot V. In work per energy it become F dot V. So next after P average is equal to P instantaneous by 2. So this many questions can ask on this. So these are the questions already asked in this formula given data. So now see. So given AN is equal to AN is equal to 90 square. So from this AN I can find out V square by R. AN means V square by R radius is equal to 90 square. Therefore V square is equal to R into 9, that equals 16 into 9 into T square. So V is equal to, if you want to multiply 16 into 9, 144, that is 12. Otherwise 4 into 3. 4 into 3 into T square. 12T. The speed is equal to 12T. So at different time, your speed is not constant. The speed is also varying with respect to time. So it is not a uniform circular motion. So you know where speed is constant in uniform circular motion. Uniform circular motion. So AN is not equal to 0, whereas AT is equal to 0. That means AT means you know rate of change in speed dv by dt. So in above question also I have given the same thing. So this is, so now your speed is varying with respect to time. Therefore it is not a uniform circular motion. This is non-uniform circular motion. That means AN is not equal to 0. The same way AT is also not equal to 0. So this equation means they'll give like this equation. If AN is equal to 90 square, 90 cube like that. So then this type of motion comes under uniform circular motion or non-uniform circular motion. So for suppose AN is equal to only 90 is given, 20, 90, something like that. So then KT like that. In terms of only T, power of 1 only given, then speed will become in. So speed will be here VRT only will come. So root T will come, right? T power 1 by 2. So T power 1 by here, T power 1 by 2, there also it will be varies with T, therefore it is non-uniform circular motion. So where acceleration is depending on T and are changing with respect to T, then speed also changes with respect to T. That is why it is non-uniform circular motion. So this point very, very important. So maybe they can ask the coming exams and all. So here about uniform circular motion, non-uniform circular motion, somewhere I have mentioned, right? So now see, when I can go to find out the, so now AT. So AT is equal to dv by dt, d into 12t by dt. So that is equal to 12 meter second power minus 2. The AT SI unit is meter second power minus 2. The SI unit of tangential acceleration is meter second power minus 2. So whereas normal acceleration is not meter second power minus 2, this is the radian second power minus 2. The net acceleration is equal to again meter second power minus 2. Which means in some questions from the given data we have to find out which is AT and which is AN and which is given A. So in the question they mentioned the rate of change, the speed increasing rate, speed is increasing. So with respect to time or in 1 second this much speed is increased. The increasing speed in this per second per minute like that is given, means that is given AT. Okay. In answer in question they have given some x into radian second power minus 2, means that is normal acceleration. So like that depends on given units and given terms. We have to find out the given data from that. So these are the very important points, notes in understanding the question in physics, right? While you want to solve your own. So for example, I will tell one problem also in this. But if you are not taking as it is like that, you'll get a different answer. So which one they have given, AT they have given or AN they have given, you don't know, you are unable to find. So automatically answer will be different, right? One example see here only. Here only one example on this small item. Question is like this, no? The motor car traveling with the speed, traveling at 30 meters a second. What is it? So V is equal to 30 meters second. So it is traveling in the circular road with the speed. Then radius is equal to 70.5 meters. So it is increasing speed at a rate of increasing speed at a rate of increasing speed at a rate of 2 meters second inverse 2 meters second power minus 2. Find the acceleration of the car. Therefore, A equal to question mark is asking. So by data it is very clear. Is asking to find out A is equal to root over an square plus 8 square. That means here already 2 meters second power minus 2 is given. This is not acceleration. Why they are asking again acceleration? This is not acceleration. So this is given like increasing speed at the rate of is given. That means 80. Okay, now then an value v square by r substitute means you will get something, right? Right. So I hope you understand this. Right. So now solution v square by r. We try. So 900 by the 70.5 means 705 into 10 can multiply above. So v square by r whole square. V square by r whole square. That is equal to 900 into 100 because 7.5 meters are there now by 705 plus into 705. So 705 only this is whole square. So that is equal to 81 into 10 power 8. 4 square 8, 10 power 8 by 705 into 705. So plus 8 is equal to 4 will come. So this if you do approximately this value will become 32. Okay. This value is nearly equal to 32 will come. So now A is equal to 32 plus 4. So that equal to 6 meters second power. This is the answer. So now coming into here in this problem means here from here I deviated to this problem. This is another question. Let's see why I deviated means here I have given one node SI unit of 80 and 80 means what, A means what, AN means what, how to calculate, how to find the difference from given values. That's why this example I have right now. So one more I'll try to give this time. So now, so here 80 came. So acceleration you can find out. Here AN at a t is equal to some seconds. AN is given means you can find out, and all these things you can find out easily. So this is about related to this problem. So on this model, one more in this model, next one is same model. So same type, that is distribution. So they have given AN is equal to KT. So asking to find P instantaneous, P average, F net. So step what, first one, what you have to find out when AN is given from this, we have to calculate the V. So V is equal to root over R into KT square. So directly I am writing. So because the above problem I have given clarity. V square by R, therefore R KT square. So this is R. So R into KT. So when V is there, I can go with AT. AT is equal to dV by dt. AT is equal to dV by dt. So that equal to dV by dt of root R KT square. So that is root RK after derivation. So now AT I know and AN I know. Therefore F net is equal to root over AN square M into AN square. So here AN is equal to K square T power 4 plus AT square equal to R into K. So this is answer. AT square. So root over R into. So this is answer. Means here T square means T power 4 will. This is F net. And here already V I got that equal to, this is equal to, I can write here root RK into T. Root RK into T. T square comes out of the root T. Because F net I know. Therefore power is equal to, power instantaneous power equal to F dot V. So that is equal to, so magnitudes Fe. So M into root over K square T power 4 plus RK into RK into. So we'll get answer. Momentum also you can find out. Power instantaneous you can find out. This is root will come inside. So M is also inside means M will go inside. Right? This is about force and power, momentum, AT calculation in this model. So coming into next problem. So very important this is. So in these two models I'm going to discuss. So let's consider here one mass. Question number. Another question. The mass is kept on the rough horizontal turning table. There is a one turning rough horizontal turning table is there. So it is turning about this axis, right? With the constant angular acceleration is given. So now axis is perpendicular, like this is the axis of rotation. So now in the distance r on the table, somewhere in the distance x or in the distance r, there is one particle of mass m is there. One particle of mass m. So now this particle also revolving about this axis with the same angular acceleration. And here friction also there, the coefficient of friction between the block and that mass and table is. So now, if you know the concept actually, so at t is equal to 0, this particle is here, and this is initially rest. The turning table is initially rest. So now the table is start rotated. Then this mass experiences force, and at one distance it will be stopped because of this friction. Then it will start rotating. Up to that it will move some distance along away from the center. The particle moves away from the center until some distance. So that is the radius of this particle now. So there it will start rotating or revolving in a circular path along this table. So I hope you understand this concept. So now here the mr omega square. So now mr omega square, the centrifugal force acted on this particle when this one the table is rotating is equal to friction. So that is equal to mu ng. So now this mm get cancelled. Therefore, r omega square is equal to mu g. So now when these two are equal, these forces are equal. Before that force are equal, when this centrifugal force is more than friction force, then it is slipped from this point, means from the center to up to this point, it is slipped. So now when these two are equal, it is not slipping. It is called without slip. Before it is slides from axis to away, it will be thrown. But when these two forces are equal, it is not moving, right? And this r omega square is equal to this net, means here mr omega square means net force here. So here we will go with a, not mr omega square. We will go with a. This is ma. Again r omega square means only it will be normal acceleration will come. A is equal to 0. So net force. So there will be mr omega square due to the rotation of turning table. Mr omega square, that is equal to centripetal force, centrifugal force away, and there is a friction between the table and this mass. So there is net force acting on this particle, that is equal to ma. So which is difference of these forces. So now this acceleration is equal to, means at what time it is not slipping, start revolving around this axis they will ask. So time you have to find out here. After what time this happens, time is equal to 1. Means the particle nearer to the axis somewhere. From rest, the rotating table is started. Then particle moves some distance, which is radius of this small particle, not the turning table, radius of this small particle. There it is started rotating along with the turning table. That is the point here. What time it happened? That is not slipping, right? Up to that time slipped. So I'm taking much time to give the concept to solve the problems other than this model. So you understand. Therefore, time here a equal to mu g. So actually generally a is equal to root over an square plus at square. So that is equal to an means here r omega square I can go whole square plus at means r alpha square. Now here r is the radius of that particle at what distance from the axis it is started revolving without slipping. Right? So now a equal to mu g, and here alpha I can write as here constant alpha is given turning table. Then alpha is equal to omega by t. So he's asking to find out t. Then t is equal to omega by alpha. So from this again you can find out alpha in this case, otherwise omega. From that you can find out the answer. Now see now. So now a is equal to means mu g square g square is equal to r square omega power 4 plus r square alpha square. So where I want t, therefore alpha equal to omega by t I can write. I can eliminate alpha by substituting omega by t to get the t answer. Otherwise, so in the place of omega I can substitute alpha into t. Both I can do. So here t will come in numerator in the place of omega I'm substituting, t will come in numerator, so it is easy to calculate. So alpha also you can eliminate, not a problem. Both will try. So that is equal to r square is the common, and here omega means alpha t. I'm going to write alpha power 4 into t power 4 plus alpha square is remaining is equal to mu square g square. If I want t power 4 t value, so this r square alpha square send that side. Therefore mu square g square minus r square alpha square by this r square will come this side. R square into alpha power 4, r square into alpha power 4 is equal to t power 4. So now t is equal to, so mu square g square minus r square alpha square by r square alpha power 4 1 by 4. So this is in terms of alphas. If you want write in omega, you can write, no problem. Means if you want write answer in omega, you can eliminate this alpha into omega. Alpha is equal to omega by t, you can write. So that is, we can try. Right. So this is one model. Next model of the problem we'll see. In the same question, so they will ask now, what is the angle made at this instant? What is the angle made by frictional force with respect to velocity? So means here the concept is your frictional force and centripetal force are in the same direction, right? On the same line along this axis, horizontal axis, and perpendicular to this axis, either j or k axis, perpendicular to this horizontal axis, either in I or j. Means it is I consider means j or k direction. So there is a AT. AT is perpendicular to AN. So now in the direction of AT, so there is a velocity, right? Velocity and AT both are in the same direction. So speed, motion, and AT are in the same direction, parallel vectors. So now perpendicular to AN and friction here. Normal force, normal acceleration, change in velocity are in the direction. Here question is asking the direction of friction and the speed. So now tan theta is equal to, I can write friction by velocity. So otherwise friction, the same direction friction is equal to here r omega square I can write. By velocity means AT direction r. So it's asking to theta value. So your friction value and v value is substituting that. So same in this direction there is a an, and in the direction AT is there. Therefore I am writing easily, and they have given answer in alpha and theta. That's why you are writing that. That is equal to omega equal to alpha square into t square by alpha. So alpha get cancelled. Then theta is equal to tan inverse alpha t square. So answer is given in alpha theta. That's why we are changing this force and velocities into in this direction of accelerations I am taking. But theta is same only now. So here if you see, so this is AN and friction direction, normal acceleration friction direction. So this is AT. So now the force, resultant force is making angle theta. So that is AN. So AT. So this is A, right? So this is a net force. So here also friction will be opposite to the net force side, a relative motion, right? So that will be, that friction makes angle with the AT theta. Then tan theta is equal to AT by means AT by AN. Sorry, AN by AT. Tan theta is equal to here theta friction, right? So this is answer. AN by AT. I have taken here some right. You can check here. The friction force is opposite to the act along the centripetal force, net force direction in the direction. Therefore, tan theta is equal to AN by AT not AN. This is AN. Opposite side by adjacent side AN by this one. So direction of friction and velocity comparison, right? So this is exactly correct in the next question. See the same like this. One more. So maximum I'm trying to view models of the problems. So on the same model with different values in different way they can ask. Right. So coming to next question. So there is a one small bead, very small mass. So fixed on a circular point at point P, circular path on circular track on point B. So the circular path is rotating about its axis. So it is omega. So now from the center, so this point is in the distance. So consider here is the point. So it is in the distance r compulsory, and here given theta is equal to 30 degrees. So now that is radius of this particle circle. So now when this circular some support table, turning table are thing, so this particle is makes horizontal circle, right, like this. This particle makes horizontal circle. So this is the motion of this particle when this rotating table or drum or something, right? Circular loop. The circular loop is rotating. On the circular loop there is a point. So this point makes horizontal circle, right? So this is horizontal circle. with angle theta, and this is the radius r. Therefore, the small radius of the particle p, circular path of the particle p is equal to r by 2. This clear. So when I know r, and they have given omega here, it is this one rotating about with angular velocity omega. So then an I can find out easily, and v I can find out. Right? An is equal to r omega square. So that is equal to r omega square by 2. And here if this angular velocity is constant, this means it is moving with constant angular acceleration, not angular velocity is constant. Constant angular velocity, angular acceleration. Then alpha is equal to omega t. Omega by t. Omega is equal to alpha t. So I can write r alpha square t square by 2. This is normal acceleration. Or if they are asking only speed, means v is equal to r omega, means r by 2 into alpha into t. Omega is equal to alpha into t. Alpha is equal to the change in angular velocity by time. So v is equal to, we can find out an. So I want to at. At means dv by dt, right? This is the speed of this particle. So dv by dt. So dv by dt is equal to r alpha by 2. So these are the questions. Now net acceleration is asking means, so an is equal, a is equal to root over an square. So an square means here this is r alpha square t square by 2 whole power square, plus at is equal to r alpha by 2 whole square. So this is equal to root over r square alpha power 4 t power 4 by 4, 2 square means 4, plus r square alpha square by 4. So that is equal to, here I can take r square by 4 alpha square common. Then it will be r alpha by 2 will come out of the root. So that is equal to, inside one alpha square t power 4 is there, and here plus 1 is there. So this is the answer of net acceleration. So similarly, like above points you can find. So next, similarly, for example, next question in this, next model of the question in this only same. So on this axis of rotation, so one particle is moving along this axis. One particle is moving with v velocity, consider capital V velocity or v naught consider. So and it is downwards is moving. So this particle is rotating in this direction. That means circle, it is making circular path with radius r by 2. So at the instant of time, t is equal to root over, they have given root over pi by 2 alpha at this instant. So this at any instant find out first of all. Then in the case of t, you can substitute the t equal to root over pi by alpha afterwards. At any instant, this particle which is moving along the, means here one thing is moving along this axis. So that is bug consider. The bug which is moving along this axis is observing the point p. So after some t, what the velocity or momentum or force is how much is asked. So now after t, this is comes to here. This particle is b at a place of p dash consider. So now here it has your two velocities, right? So one is towards the center, another one is tangentially direction. Two velocities are there. One is towards center and another one is tangential. Tangential velocity and as well as normal velocity. And see now, if this one observing means the relative velocity will be the relative velocity of particle p with respect to bug is equal to velocity of particle p minus velocity of bug v naught. So now velocity of the particle t at any instant I want to find out. So let it be v consider, that is v. So you can find out v is equal to your an square. We already have got, it is at t r alpha r by 2 alpha. So now here if you see with respect to him, this one have two components. Okay, v is two components. So that equal to v cos 45. So now for example, this bug is direction is, this is y axis is given. So now the p has two components, that is one is I component and as well as k component, right? Plus v into cos 45 k component. So this is I, this is. So for this position, so the v is have two components, one is cos 45 and sin 45. So both of them cos 45. So one is cos means and one is sin. In the 45 case, both you can take same only, right? Sin and cos both are same. So no, sorry, right? So now that is equal to v is equal to totally v naught. So this is j cap I have taken, therefore minus j cap. So here already v I got here, v is equal to r alpha by 2 into t plus r alpha into t by 2 root 2 plus r alpha into t by 2 root 2, this is k cap, this is I cap. For example, this one is given I cap means this is j and k. So now t, the given t value substitute means you get the answer. So when velocity you got it, then momentum you can find out. By time is force, this is velocity, right? So you get answer. So this is one type of. So next model of the problem. Consider two masses here, equal masses, these two are. So connected by 4 strings. So these two are the strings of equal length. These two are also strings equal length. Here one mass is connected. So that is F naught force is acting. Some force mg. F naught equal to mg. So let's take some points here. This is A, B, C, D. And the C is fixed. And now C is rotating about this axis. That means this is these two masses are rotating about this axis, the constant angular velocity. So here this is theta 1, here this is theta 2. So then this one also theta 1, this is also theta 2. Because these two are on perpendicular line like this. Means these two particles makes horizontal circle like this, right? So those two are moving on this circular path when it is rotating with constant angular velocity. So omega is equal to constant, right? So now in this, so you ask the ratio of tensions here in this string. All are equal length. The L is the length of the string and massless. The strings are massless. The length of strings. So now here this is considered as T1. Here T is equal to T2. So tension is always here pulling, right? Normal is always pushing. So T1, T2. The ratio of T1, T2 they can ask. So the ratio of T1, T2, you want T1 by T2. You must know the T1 and T2 values. So here sometimes they will give this is 90 minus theta 1, this is theta 1, this is 90 minus theta 1. Sorry, this is 90 minus theta 1. This is also 90 minus theta 1. So all are arranged like this perpendicular. These two rods are perpendicular, these two are perpendicular. So this is also perpendicular here, right? So 90 minus theta 1, this is theta 1, 90 minus theta 1. So now if you take here T1, T2, so this particle vertical equilibrium, this particle is in vertical, these two particles are in vertical equilibrium. That means, so here there is a T2 components, T2. So this is 90 minus, this is theta 1 means, so this is also theta 1, right? So T2 cos theta 1. So in this direction, so there is a T1 and mg. So mg is acting, and if it is 90 minus theta 1 means, so this is here theta 1, this is 90 minus theta 1, right? So this is cos of 90 minus means T1 sin theta 1. T1 sin theta 1 plus mg. So this is in vertical equilibrium. If values are given theta 1, you can separate. So therefore first equation is equal to T2 cos theta 1 is equal to vertical equilibrium T1 sin theta 1 plus mg. So this is equation 1. So whereas it is rotating in a circular motion, therefore there will be a T2 sin theta 1 and T2 cos theta 1. That means T2 sin theta 1 plus T1, this is 90 minus theta 1, here theta 1, 90 minus theta 1, so here theta 1. Therefore T1 cos theta 1 is equal to ml omega square I can write. So on one particle only I am taking, right? So in both the sides means you can multiply to, both are same concept they will follow. So here also say this on particle D also same equations. So now ml omega square according to Horzantal circular motion. So I will give the concept here about Horzantal circular motion. See, so this is the particle suspending like pendulum. It is making a horizontal circular motion when this is rotating about this point. So this particle is making horizontal circular motion. That means, right? So this particle is making an angle theta. Tension this is. So now this tension have two components. One is T cos theta and T sin theta. So now here T sin theta is equal to mr omega square. And from this is r, radius r. So this is, and this is length L. Hypotenuse is L. Therefore, r is equal to L sin theta. R equal to L sin theta. So now T cos theta is equal to mg. in horizontal circular particle is moving in horizontal circular motion, then tan theta is equal to r omega square by g, that is equal to v square by g, v square by rg, v square by rg, that is equal to v square by r into g. So this is tan theta value. Okay, here and here tension I want to find out. So see now from this equation, t into sin theta is equal to m into L sin theta omega square. So sin theta get cancelled. T is equal to ml omega square. This is from horizontal circular motion. Will bring it. The particle moving in horizontal motion. Here t sin theta is equal to ml omega square. Here sin theta 1 plus t cos theta 1 is equal to, they are moving ml omega square. Means mr omega square. R is equal to L, both are same only, L sin theta 1 I can take, or cos theta 1. So now, so here mr omega square consider better, that is ml. Here only t means here t theta I have taken, therefore in the place of L we can substitute r, right? R mr omega square, then r is equal to in theta 1 you can write in terms of L. Therefore r equal to L sin theta 1 right here. So now for suppose here, for making easy, means to get the clarity, more clarity. So consider theta 1 and theta 2 both are equal at some different values. So let theta 1 is equal to theta 2, that equal to 45. So now first we will get t2 plus t2 by root 2 is equal from the first equation. So this is the second equation that consider. From the first equation, t2 by 2 is equal to t1 by root 2 plus mg. Therefore, t2 minus t1 is equal to root 2 into mg. This is third equation. Let this equation is third. So now, from the second equation, t2 by 2 means t1 plus t2 is equal to, right I am writing t1 plus t2 is equal to, so root 2 into mr omega square into root 2. So now here r is equal to L sin theta 1, so that equal to sin theta 1 is equal to 45, therefore ml omega square t1 plus t2 is equal to ml omega square. It is equation 4 concept. So now add these two, means to get the t1 or t2 ratio, okay, now add 3 plus 4, add third equation and fourth equation. So t1 is eliminated, therefore t2 is equal to 2t2 is equal to, from adding 3 and 4 equation, so t1 is subtracted, therefore ml omega square plus the root 2 into mg. So it will come this side down, therefore t2 is equal to 1 by 2 into ml omega square plus root 2 into mg. So when t2 you can substitute the t1 and you can find out that. Now let this t2, this is equation 5. Now take another equation. So then this t2 value substitute here in the t1. So then t1 is equal to t2 minus root 2 mg. So that is equal to t2 is equal to ml omega square by 2 plus root 2 mg by 2 minus the root 2 mg. So this is minus root 2 mg. So this is equal to ml omega square by 2 minus root 2 into mg. So if you take m by 2 common, that is only m by 2 I can take common, then L omega square, so here also by 2 is there, minus root 2 into g. So this is t1. So now here f naught they will ask. So f naught is equal to, from the free body diagram, that is equal to 2 t1 into cos 45, because t1 equal to t2, therefore cos 45. 90 minus theta 1, 90 minus 45, 45. That is why for easy purpose you have taken. 30, 60 also you can take, 60, 30 will come. So now that is equal to 2 means 2 t1 means get cancelled. Cos 45 means 1 by root 2. That is equal to ml omega square minus the root 2 mg by 2 into 2 into 1 by root 2. Cos 45 means 1 by root 2. So 2 get cancelled. That is equal to ml omega square by root 2 minus mg. So this is f naught value. Right? F naught is equal to some mg is given, means here also suspended mass also same is 2 mg, that equal to L omega square equal to root 2 will come. So there will be different cases from this second, right? Right. So this is about Argent sector motion, some model problems. I will make one more video on the same topics, Argent sector motion. Right. Thank you.